Okay,
No, it's
so
not really.
it's funky ordered.
Yeah.
So I want to calculate the flux of a vector field F is minus y x x
Okay.
through the square with corners, and these are way out of order. The origin, 1 over in the x, 1 over in the y, and 1 over in both x and y. Because that's a square now.
Yeah.
Right.
Yeah.
Yeah, I don't know what I was thinking.
No Z.
My order was a little dorky. Yeah, so there's 0z, right? So that square is down here.
Yeah.
Right, there's my surface S. And I want to calculate a flux of a vector field through this thing, right? Okay, so I should do the integral over my surface of F dotted with dA. Right? Where did I get that thing from? Like, why did I start writing that down?
Why should you start with-
Yeah, because that's the idea, and they said
Yeah.
flux, right?
Yeah.
So once they said flux, I was going to start writing this down.
Yeah.
Now I need to spend a second to think about my surface. So here's your S. I need what?
You need an area, a surface area.
Which is 1.
How about I need the integral over S of F dotted with,
dx dy.
good, I'm going to need a d area. But what's this thing?
Well, the normal vector.
See, I need a normal vector for this thing.
But it's unit length, so isn't it just 1? Or
But
it
which
needs- it
way
needs-
does it point it? Does that make sense?
yeah.
Like, it's a unit vector. It's got to be a unit vector, but I need to establish which direction it points in.
Okay.
Z positive.
Perfect, right? This thing's in the xy plane, right?
Yeah.
So I'm looking for a normal vector to it. So that sticks straight up. And I need it to be 1 long. So what's the vector that points straight up 1 long?
Just 1.
0, 0, z or k, right? So I should be doing an integral over my surface of f dotted with k, right? D area. And now I can fill some of this in. So I know that f is
Negative
minus
y.
y xx, and k is
K is just 0, 0, 0, z.
0, 0,
1.
One.
Yeah, that's right.
Yeah, it's got to be 1 long, right?
Yeah.
And this is a little weird, right? Because this doesn't depend on any variables,
Yeah.
which really is saying that this thing's flat, right? It's part of a plane, so it's normal vector, right? It's constant.
Okay.
Okay, and then I need dy,
Dx dy.
probably dx dy, right? Which means that over here I wrote 1 integral sign and I need
2 double
2. Got to be a double integral. Where do the x's go?
0 to 1.
Okay, on my shape they go from
0 to 1.
0 to 1.
And 0 to 1.
And the y's also go from 0 to 1. You guys see that?
Yeah.
So I get the double integral, 0 to 1, 0 to 1, of, what's the dot product here?
Just x.
X, dx, dy.
And then you're just going to get 1 dy. Oh, no, 1 half dy.
Perfect. So I get 1/2 the integral from, sorry, the integral from 0 to 1 of 1/2 dy gives you
1 half.
1/2.
But what does that 1 half mean?
What does that mean?
Does that mean it's
Like half.
50%?
So is it like easier to go through the surface?
So this means that there's a net flow through the surface, right?
50%.
So if we had,
Of a half of unit of volume per time unit.
yeah, I was gonna say if we had units, it'd be a half of whatever that unit was per time.
Per time, right?
Okay.
This is telling you, right, in 1 time unit, how much stuff goes through it. Half a unit.
Okay.
You guys see that?
So it's probably coming at.
Yeah, so if I thought about this vector field, right? This is a vector field that you guys recognize that one. In the XY plane, that's rotation, right?
Mm.
And then what's it doing in the Z?
Following the X.
Well, it's going up as far over as it is, right?
Yeah.
You guys see that? So, the further this way I go, the more up the vectors point.
Okay.
And then they're kind of twisting in the XY. But really the thing that's mattering there, right, is only the Z value. Why is only the Z value mattering?
Because we have a flat.
Yeah, because the thing's flat, so twisting doesn't put any stuff through the plate. You guys see that?
Yeah.
Like if I thought about a kind of separate but similar example, if I did F is minus Y, X, and 0.
Well, then there wouldn't be anything happening.
Yeah. Right? Because this is just at every level, it's spinning.
Yeah.
And so how much is going through the plate?
0.
Well, a little bit is entering this side, right?
Yeah.
But it's leaving that side.
Oh.
And the plate has no width, right?
Yeah.
So really, although I'm saying something's entering this side, I mean, there's no volume there. You guys see that?
So it's like skimming off the top.
Yeah, it's just kind of, it's rotating around the plate, right?
Nothing's going through.
Nothing's
So
just
nothing's going through the plate at all.
It's just bouncing off.
Yeah, it's just parallel to the plate.
Okay.
We're spinning a
Is that-
little bit. Check one.
Cool?
Yeah.